In this video, we're going to look at conservation of momentum questions, and we're looking at type 2, where the objects will collide and then join together afterwards. So the first part of the question we've seen here, it says a diagram shows a car and a lorry about to collide. We're given the velocity of the lorry and the mass of the lorry moving in this direction. You're also given the velocity of the car and the mass of the car, but this car is travelling this way. Two vehicles then collide and become locked together. I want you to calculate the speed of the vehicles immediately after the collision. I want you to show your working, but there's no need to change units. You can leave it in kilometres per hour and tonnes. So the first step is to work out the momentum of the lorry. So we can work out momentum by doing mass times velocity. And we can see then that if we do mass times velocity, well, our lorry has a mass of 9.5 tonnes and a velocity of 20 kilometres per hour. So you do 20 times 9.5 and it gives you an answer of 190 tonnes kilometres per hour. So the next thing to do is to find the momentum of the car. So we're going to use momentum equals mass times velocity again. We're now going to use the 0.5 for the mass of the car multiplied by the minus 40. Now the reason it's a negative 40 is because the car is travelling in the opposite direction to the lorry. So you've got to indicate that by using a minus. So 0.5 times minus 40 is minus 20 tonnes kilometres per hour. Now we know the momentum of the lorry and the momentum of the car. We can find the total momentum before by adding those two values together. So you can see that the total momentum is equal to the momentum of the lorry plus the momentum of the car. We put the numbers in that we worked out, so you get 190 plus the minus 20. That gives an answer of 170 tonnes kilometres per hour before the collision. So in terms of marks so far, we picked up 3 marks for this question. We got 1 mark for correctly calculating the momentum of the lorry, 1 mark for correctly calculating the momentum of the car, and 1 mark for finding the momentum before the collision. What we need to do now is work out the total momentum after the collision using the conservation of momentum law. So now if we move up here, you can see the conservation of momentum means that the total momentum before a collision is equal to the total momentum after a collision, which means that our total momentum afterwards is going to equal 170 tonnes kilometres per hour. So you can see that we've written in and got ourselves the next mark by writing that the total momentum afterwards is equal to 170 tonnes kilometres per hour, because that was the same as what we got before. So now after the collision, what we get is we get the lorry and the car sticking together as shown here, and then moving away together in this direction with velocity v, and we need to work out what velocity v will be. So we're going to use the equation that momentum is mass times velocity. What we're then going to do is substitute the values in, so we know that our momentum is 170 and our mass is going to be 9.5 tonnes plus 0.5. Putting those values in, we get 170 is equal to 9.5 plus 0.5 multiplied by v. So you can simplify this down to get 170 is equal to 10 times v. And once we've got 170 is equal to 10 times v, we just need to remove the 10 from the side of the v, so we'll do 170 over 10 is equal to v. So 170 over 10 equaling v, so therefore our velocity is going to be 17 kilometres per hour. So we can see there now that we've got the 17 kilometres per hour on the screen being the correct answer. That gets you the final mark. And the previous mark, because this one question out of 6, we'll be forgetting the idea of 170 is equal to 9.5 plus 0.5 times v. So the idea that you've calculated the mass when they combine together. And that brings you to the end of this question. So you can now move on to complete the type 2 conservation of momentum questions on your worksheet.